welcome to the next topic on our lecture. And today we will start a new chapter, and it is related to the sensor. We will have two lectures on this chapter. And today we will focus on the sensors as in general, and the process of signal acquisition, meaning the contact between the physical environment and the system. Because the next lecture we'll have about once we have the signal acquired, to see how we will condition it. Okay, so let's start. What is a sensor? Okay, first of all, its origin comes from the point of view that a system should sense the environment that is around it, and we can make a relation to our sensitive organs, like, okay, we can see, we can smell, we can touch, we can taste, we can hear something, okay, and all the information about the environment is sent to our central processor. And the biological terms, it's our brain. Yeah, our brain has the role of the processing unit, and it's making decisions. But first of all, before taking any decision, it should collect or gather all the information that is around. Okay, so sensors are for collecting or gathering information from the physical environment. Yeah. Okay, we will have here some video. Maybe you can after see what means a sensor from the YouTube. Yeah, you can, of course, you can see other reference about that. We'll not go deep inside, but let's see where we can collect data and where what is the physical environment that we can we usually see that we can gather some information. Okay, in our daily life, we have everybody has home, yeah, more or less, yeah, and there sometimes you have some behavior to make your let's say human being, let's say like this, more comfortable. And usually if you are staying in house and see that, okay, it's cold, let me switch on the boiler, yeah, or to switch on the heating. In this case, okay, we are feeling that it's not good or it's good, or I see that it's not too much light, yeah, I'm sensing by my eyes that is not enough light, and as a reaction I have to switch on the lighting. Or let's say we have here some cameras, okay, I will want to go, I'm going to see on the window that somebody is coming, but somehow we would like to automate this process, and this is why we want to replace or to have a kind of add-on to our sensor. We will add some additional sensor. First task being to stay in our sofa, let's say, and or staying in the bed, and everything to be automated. Yeah, and for that we need additional equipment. Yeah? So where is this equipment? Usually this equipment is installed everywhere in the house. We see for lighting, we have some sensing for lighting, we have some automatic switching, we have some sensor for temperature, for humidity, for everything else, and it is the house start to provide information about the house or about the home environment. And after, okay, in the next steps, in our case, in our next chapters, we'll see what we are doing with this information. But we had a lot of sensors that is helping us to know more about the physical environment. Let's say motion sensor. We can see that anyone is in the room. Yeah. Humidity or temperature sensor to see what is the temperature in the room, what is temperature outside, and we can adapt it to more comfortable temperature. Let's say in the summer we want a little more, about 19 or 20 degrees in the room, but in the winter we would like to have, or the comfortable temperatures about 20 or 21 degree. This is an average. Why? It is our feeling, let's say like this. In the winter I want more to be warmer, and in the summer I would like to have more cooling. Yeah. Okay, but this is how we collect and where, in this case, what we need, and this is how we gather the information. We install everywhere in the house the additional sensing elements additional to our, okay, as a human. Yeah, okay, but let's see what is a sensor. Okay, so the sensor, let's say, it's giving us the interaction with the physical environment. Yeah, let's start with some painting. Yeah, so we are speaking now about the environment interactions. Yeah, because sensors and, let's say, interaction with the environment will have via the sensor for gathering and the actuator in order to make some changes to the environment. Yeah, but last time we discussed about the user interaction, and user interaction usually is built on some special sensor and actuator that are adapted to the human behavior, because, okay, it is providing us information, let's say, in text. So our sensor can read text. Okay, our sensor gather the pictures and our brain is interpreting it. Yeah, but somehow we can adapt the actuator in order to provide us information that we can say. And in this case, we control both sides. Okay, we understand information and we develop the system in order it to provide information exactly how we understand that. And vice versa, we have some behavior and we develop the sensing in order to understand our behavior, let's say a touch or some words. In this case, we control both sides. We are providing information and we adapt the system in order to understand this information. Okay, a touch, okay, I'm touching, so on the other side I'll put a button, so I will detect this touch. But it's somehow, let's say, different. The interaction with the environment is somehow different because we have a lot of uncertainty, how to say better, in the physical environment, because we have to detect some things that we are not controlling. Okay, in case of temperature, okay, it's not so complicated to gather the information about the temperature, but there are some more complex environmental states, let's say the electromagnetic fields. Okay, yes, we can have some let's say some wires built on some shapes, and in this case we can do that. But what about the electronic or spin? Yeah, in this case, yes, it's not so easy. Yeah, because we have to build some complex system like I don't know how to say in English, resonance electromagnetic resonance system that is detecting everything in our body, and it is providing even higher resolution information than X-ray. Yeah, in this case, these sensors are very, very complex. Yeah, and we have to adapt to the environment. So this is the difference between user interaction and environment interaction. User interaction are just there are also some sensors, but in this case, in the case of user interaction, we control both sides and we can adapt if the system to our behavior or change our behavior in order to, let's say, to activate a specific sensor. In relation with the environment, it's something somehow different. Of course, and we have the device interaction, and somehow it is also related to the sensor actuator. Why? Because let's say we are sending 1 or 0, we have to sense it is 1 or 0, and we have to measure the physical parameter voltage. And in this case, yes, it's somehow related, but it's quite different. And the communication usually and sensing actuating in the communication field, it's somehow also can be controlled or adapted. So the most important or the biggest challenge of the sensing or and actuating too is the interaction with the environment. So we want to read physical environment, and after that we want to provide some reports or action depending on that. So let's have a short definition of what is a sensor. Maybe somewhere in wiki or other dictionary you can find other definition, but in our lecture we'll have the following definition: is the a collection of components made by mechanical engineering, electrical engineering, and software engineering that are transform the physical values, okay, into an internal signal of the system. So internal signal of the system depends what is in this side. Okay. So we can have some components, only mechanical not, but we can have sensor that are providing us some electrical signal. Or we even can have some smart sensor that could have some microcontrollers here, and in this case the system will be the software system and the software world. But anyway, the sensor, what the sensor is doing is converting the physical changes into an internal signal or measurable signal. Okay, so now let's go deeper, a little deeper, and we'll see that in case we have some components as a sensor, we will have always two parts of that. One of those parts is responsible for sensing, and second part is responsible for adapting or transforming information that is providing the let's do different. Okay, sensing is converting the physical changes into some changes in the material. And transducer is measuring those changes and converting it to the signal, internal signal for internal signal of the system. So sensor is sensing, transducer is converting this measurable value into an electrical signal. So let's have an example. This example, here we have a sensor, a temperature sensor. This is a real temperature sensor, and it is converting the temperature into a measurable signal, and we can measure by a ruler this value, And we can see, okay, we have here somehow about 21 degree or 22 degree. Yeah, okay, but we cannot use this sensor in order to make some automation. Why? Because we don't have it, this signal, okay, or this measurable value adapted to our system. In order to have it adapted to our system, we need a kind of a compatible signal with our system. And we can have or electrical signal or even some variables. Yeah. So in this case, such sensors like temperature or humidity, we cannot use in automation. We can use it from home use, and we can use by sensing it by our sensors, but we cannot use it for automation. For automation, better to have some specific sensors, like this, what is here. And in this case, this one will be the sensor, and the second part will be the transducer. That is converting the measurable or the changes of the material. In our case, it can be, let's say, resistance of the material. Yeah, what means resistance? That means the current cannot pass through freely for this. And here he will have a thermoresistor that is changing its properties, and the current is passing easier or harder through this resistance. Okay, and transducer is converting this measurable value, yeah, the resistance, into a signal. In our case, can be an electrical sensor, electrical signal, and we can measure it by I don't know, analog digital converter, or we'll see further how we can do that. So, but anyway, here we have more specific figure. But anyway, according to general rules of the system, we have some inputs. In our case, is physical environment. Yeah, here. And it is providing the inputs to our sensor, let's say like this, like here. Yeah, something is happening here. We are processing it, and on the output we will have something that we can use. Okay, now depends what kind of technology we are using to define this component. We can use mechanical engineering, okay, electrical engineering, and there are cases where we can use the software engineering inside of the sensor, or even the components or the components drivers from our software, okay, can be considered also as a component of the sensor. So we have a software component of the sensor. Okay, then. Let's go. Now, let's go further then. So, now let's make some clarifications, or better say, to classify the sensors according to some criteria in order that to be able to decide easier what kind of sensor to use, because from some information we can have in the world, we have about 3,000 types of sensors with some modification, okay, that can be used around the world, but some of them are better for something, for other thing, and in this case we have somehow to classify this information about the sensor in order to have exactly what we need. Okay, so the first criteria that I would like to introduce is parameter type or parameter kind. What kind of parameters we want to measure? And in this case, okay, we will have a big storage of the components. Okay, this is here are the temperature sensor, humidity, sound sensor, and so on. Why? Because it's very important. Not every sensor can do anything. Yeah, and in this case, we should see that. Okay, for temperature sensing, we should select some materials or some construction, mechanical construction that is sensitive to the changes on a specific parameter, humidity, let's say. How we can build, by the way, humidity sensor. We know that the water is conducting the current, so we will need a kind of substrate or a material that is adapting the level of the humidity from the environment. Let's say we have a sponge, SpongeBob, yeah, okay. So in this case, it will gather the humidity from outside, and we will know that water is conducting the current. What we can do? We just will measure the resistance of that, and we will adapt it, okay, by laboratory, some experiments. We can say that in case we'll have a value of resistance, in this case we have specific level of humidity. Similar to the temperature, okay, we can have some materials that is changing its properties according to some a level of temperature. Similar for everything, we have to choose the specific material or sensor that is sensitive to a specific parameter. And we can say we are measuring temperature, humidity, sound, electromagnetic field, movements, positions, let's say, level of the water, global positioning, distances or pressure, let's say like this, lighting or color. Having a let's say a matrix of color sensor, we can have a camera, and so on. So this is okay. It's not the full collection of the parameter that we can use. We just should detect what we want to measure, and we should select the most appropriate sensor that is sensing exactly the parameter. By the way, we can have even the parameter kind. What kind of temperature? Okay, we can have low temperatures, and high temperatures. And some sensors are good for low temperature or room temperature. Some of them are, let's say, for the sun temperature. Okay, how we can measure the temperature of the sun? Okay, we can send a sensor by a rocket to the sun, or why not a color sensor? But we should understand first what is the parameter and what are the properties of this parameter, and to select exactly the proper sensor. So the first one is the parameter kind, or better to say parameter nature. In order to select the most appropriate, let's say, sensitive material or sensitive let's say measurement method, mathematical method maybe, or I don't know, because some of the sensing we can measure something, but according to some assumption and mathematical model, we can assume it's a kind of ultrasonography. We are measuring some echo location, but after that we see that as we will insert a camera inside. We are measuring sounds, but providing images, and this is another thing. So in this case, we should clearly understand what we are measuring and what is the parameter measure and what is the effect we are using in order to measure the parameter. It's very critical. Why? Because in this case, we will detect exactly the proper sensor for the proper environment for the proper parameter. Okay, next classification. Let's say we found the proper sensor for what we need, but we will go to the next step, to the interfacing, and we have first type of interfacing. The simplest way is the binary. We are measuring presence or absence of some values, let's say. Yeah, so we can detect it's hot or not hot. Okay, we can say if not hot, it's cold, maybe, but we can say that it's hot or not hot, or it's cold or not cold. Yeah. We have enough light, we don't have enough light. Somebody is in the room or not. Yeah. The door is closed or is opened. And this kind of sensor, we will say that we have an interface, and this interface is binary, that is providing us values ones or zeros. Okay, and of course we can use this information. Now I will introduce another parameter that is related to the domain, or how many values we have in the domain. Okay, in the domain of this sensor, we will have what is the resolution of this signal. Can you give me some feelings about that? What is the resolution of this signal of, let's say, so regarding the resolution, we can say, okay, how many values in the domain we have? And in this case, we have only two values, yeah, and our resolution will be 2 or 1 bit resolution, 2 on the power of 1. And we can say we have a resolution of 1 bit or 2 values. We cannot have, let's say, a resolution of 1. Why? Because we can have or not have, true or false. And in this case, the lowest resolution will be 2. Okay. Why we are speaking about that? Because we will have the next limit of the resolution, and we'll have the analog interface. Analog interface. Analog interface is usually more appropriate to the real world. Yeah, the physical environment, and usually we are measuring, let's say, temperature. We are measuring in degrees, Celsius degrees. Yeah, or when we are measuring the length. Yeah, or we are measuring the speed. Let's say. Yeah, we are measuring it in some values, and usually the real world, the values in the physical environment usually are continuous value. What means to be continuous? What means to have a continuous signal? Okay, continuous is not interrupted. It's a kind of string, or how to say, yeah, or so that means in case we will have a zoom on this area, or let's say even smaller, let's have this one, yeah, and we'll have it like, oh, sorry, let me adapt it. Okay, let's think that we have this signal. We want to see what is here. Okay, zooming it, we'll have like this. We'll go even deeper. We'll have, okay, zoom. Yeah. We'll have like this. And doesn't matter how deep will be our zoom, we'll see that we don't have any interruption here. That means it's a kind of on a straight line. Yeah, always between 2 points we'll have the third. That means to have a continuous line. Yeah. Okay. And in the real world we have an analog value, and usually some sensors can provide us analog signal. That is meaning that it's converting from the pi, let's say, to another value voltage that will also be a continuous signal. In order to have it inside of the microcontroller, we will need an additional converter, the analog digital converter, that will convert it to the discrete value. Discrete means we have values apart. So let's see, we have a continuous signal, and in the points when we are converting it, we can have discrete signal. That means we have points apart. Let's say we can have this one, after that we can have this one, and we cannot have something in the middle. Never. Why? Because the resolution of this signal is lower. So here we have the resolution, the infinite, meaning we in the domain of the signal we can have infinite number of points or defined points. Yeah, infinite number. Why? Because zooming and zooming, and we'll see that never ends. We'll have a continuous line. But according to the technology of the ADC, it cannot convert infinite resolution. It always will be limited resolution. Let's say it can say that, okay, I can convert and be sensitive to 0, 0.4, let's say 0.8, yeah, and never can collect some information. Why? Because in this part we have 0, 1 means 0.4 volts, 2, 3, and why? Because we have zeros and ones. Okay, binary system. Okay, we cannot say that I have a binary on 8 bits and will have half of the bit. Never. Yeah, so when we are digitalizing it, we are limiting the resolution according to the limit of the ADC. In this case, once we have, as in Arduino, we have 10-bit resolution. That means we'll have 2 on power of 10, and it will be 1024 values per domain. The maximum value will be 1023 from 0 to 1033, and it will be related to 5 volts from 0, yeah, from 0 to 5 volts. And now converting it, and we can somehow map the converted value to the voltage, and we will have some discrete values. Yeah, discrete means apart. We never will have value 0.2, except we will twice the resolution. We will have another, let's say, 11-bit resolution, and in this case we'll have 0, 0.2, 0.4, and so on. Yeah, and here we'll have what? 2000, and 45. Yeah, 47. Oh, middle 2048. Yeah, 47. Okay. So now, having the analog interface, we will never be able to collect the high resolution signal. Okay, we can have a limited resolution. So the analog signal is the highest limit, let's say. It has a highest limit of resolution, meaning infinite. The binary has the lowest resolution. So yes and no, true and false. And we have the infinite resolution, but it is limited by the method of gathering information. So in this case, we can have, let's say, a resolution of 10 bits, 11 bits, 12 bits, 16 bits, 32 bits, but not the endless. Why? Because rising 1 bit of resolution, we need to add additional hardware components inside of this microcontroller, and we will have bigger or higher cost to have such systems. Okay, but infinite never. High resolution, yes. Infinite never. But to have some association with the resolution, we can say, you can just write me in the chat what is the resolution of your display. Okay, and most probably some of the regular display or all display, let's say, will have a kind of 600 on 800 pixels. Yeah, there the domain of the resolution is defined how many pixels in the domain, okay, of the display. In our case, we are speaking about how many values we can have from the minimum to maximum. This is the resolution. Okay, we can say that we have how many values, or we can say that we can have 2 on power of what? Of x. X being the x bit resolution of the signal. Yeah. So once again, here analog infinite resolution. Here we will have, let's say, 10-bit resolution. That means we'll have some stairs. Yeah, this one. Or, but this one is another thing. So always we are losing information once it is converting. More than it, we are not losing only the information from the value resolution. We are also losing the information because, let's say like this, the system is doing, it's working generally like this. It's gathering information and providing to the output. And the next iteration is gathering information and providing into the output. And meanwhile, something could happen. Let's say in this point, we can have a kind of peak, and we will never see that. So meanwhile, we can gather information only on the certain points, and we can have say that we will have time resolution. And time resolution will say how many samples we can have per second. And in this case, most probably you already heard about the frame FPS, frame per second. That means how many frames the system can provide to the output. But this is, it depends of the hardware, how sophisticated or how complex it is. Okay, so the resolution means money, or means hardware costs, and sometimes it's enough for us to have the binary. I want to see if it is day or night. In this case, why not? It's enough. I don't need to see the luminosity after that to see if it is day or night, and we can use a very cheap sensor. But sometimes we need to see what is exactly the temperature. Because let's say it could be very critical in the situation of the let's say chicken, or how to say, yeah, incubation. Yeah, some changes of degrees will change the gender of the chicken. Yeah, not chicken. Pui, how to say. So, in this case, is very critical, and we will need a high resolution maybe in order to control, but most probably in laboratory. In case we don't need exactly, we'll say that okay, it's good temperature or not good. Okay, so let's continue then. So the second criteria is interface, but now I need from 1 to 10 the level of understanding of these classification criteria, yeah, the interface and analog and binary. What is the difference? Waiting for your answers. Others? So binary signal is one limit when we have only yes or no. Analog signal is infinite resolution, but it's limited to the technology that is gathering it. So unusually analog digital converter is losing the information in time because it cannot always follow the signal, and it's losing information in the resolution because it is limited by the hardware to the how many values per domain it can measure. It's a kind of an ADC. We can have some comparator. It's lower or less than a certain value. After that, lower or less than that second value, and so on. So on this, that means every value needs additional piece of hardware, and for everyone we'll need more. But depends on the construction, of course. Yeah, but the source of the analog signal we can have on this potentiometer. So it's a variable resistor, and we can make some, and we will see. In case we'll measure it with 10-bit resolution by the Arduino, we'll have from 0 to 1023. But we can have, let's say, another microcontroller, let's say MSP32. No, STM. Yeah. And STM micro, there we have a 12-bit resolution. That means we have, okay, for 11 we'll have 2048. Yeah. For this we'll have 4092 bits. Yeah. And in this case we'll have the values from 0 to 91. Yeah. So depends of the microcontroller, and in this case we'll have somehow associated with the value. But we'll see that in the next lecture how to convert the values from domain of the raw measuring back to the voltage. We will see that in the next lecture. So let's see your level of understanding. 8, 8, 9, 10, 7. Okay, it's at the let's say good enough level. Yeah, let's go further, because most probably you'll not have too much to fight with that, because most probably you'll choose to use a digital sensor. What means a digital sensor? Means that it is, let's say we have here a kind of sensor, something between, and we have a digital interface. So digital interface, that means we are already processing it, yeah, and it is providing already processed data. Even we can have not in the digital as numbers, but we can have even in text. Let's say now we can see that the GPS system we can connect it to USB terminal or serial terminal, and we can see that everything is in monitor and it's reporting text, additional information, positioning, city, and so on. Yeah. So in this case, we can choose already high performance. More than it, it's becoming in the time cheaper and cheaper. So in this case, we can use digital. Yeah, this is why I said maybe you will never use that. But of course, simpler analog Sensor always will be cheaper. Why? Because it has it doesn't use additional hardware in order to process it and to prepare the information. Okay, so according to the digital interface, we can have parallel ones and serial. Parallel means when we send many bits at once in parallel. Yeah? Serial means when we send bit by bit as a train, let's say. Yeah? First bit, second bit, and so on. So in this case, can you say, what do you think? Which of the interface is better? We'll discuss after, yeah, about that. But let's see. What do you think? Serial, just write on P for the parallel and S for the serial, or 7 and 5, 7 for parallel, 5 for serial. Waiting. It's good to participate, because once you will give me an answer, that means you already have something in mind, and we will say see if you are right or not, and why you are right and why you are not, and when you are right and when you are not. But please provide me some information. What do you think? Which of them is better? So meanwhile, I'll receive the answers. I will start again with the initial values. Yeah, here in parallel interface, we are sending 8 bits at a time. Here we send 1 bit in a cycle. Yeah, so apparently we can say that okay, this interface is 8 times faster, and yes, it's faster. It's faster because it's 8 times faster. Yeah, but the serial is cheaper, and in this case, if I want a cheaper solution, I will select serial interface. Why? Because I have only one wire. Okay, slower, but what I can do? I can raise the speed 8 times. In this case, I can have similar speed. Now, what is the problem with the parallel? Let's imagine we have our phone. Yeah? We have our phone and we would like to transfer some information. Okay, of course, we have here some antenna. Let's say this one. Yeah, we have here antenna. And how we transfer information between two antennas? Here we are applying some voltage, yeah, and applying some, not voltage, but let's say some power by a frequency, a certain frequency. Yeah, and it is starting to excite the around the environment, creating electromagnetic waves. And the second, it's sensing the electromagnetic waves and gathering information from this point. Yeah. Now, depends of the frequency. If the frequency is higher, in this case, it can penetrate even harder materials. Yeah, usually lower frequencies are going farther. Yeah, but it's passing some obstacles. The higher frequencies are going through the materials. Yes, but not too much materials. Yeah, but it cannot pass it. This is why we can say that higher frequencies going through, lower frequencies are passing obstacles. Yeah, but going through, we are losing the energy. Yeah, so this is why higher frequency we cannot send it far away. But we would like to reach also the higher speed on the parallel interface, and on the higher speed, those two, let's say, wires will generate some noises around and will influence that. And that means that we will have some problems here. Let's say this one somehow can influence this wire, and it can be interpreted as logical 1 instead of 0. So we'll have noise and we'll have losing the data because the data integrity will not be ensured anymore. So on low frequencies, it's okay. We are sending 8 times faster, but rising the frequencies, we will have a problem with data integrity. So now depends of course, the length and the parameters of the wires. So for the short wires, it's good to have parallel, but for longer, better to have serial. Why? We can, of course, protect somehow this wire by inserting the wire inside of the shield, yeah, and sending it. So it will be protected, but this means we have some material to spend, yeah, and material cost money, and high quality material even more money. So it's cheaper to protect only one wire than 8. So here we can rise to reach very high speed. And now, of course, in the serial interface, we don't have only one wire, we have less, but for sure we have less wire. So we have the clock, and we can, let's say, filter some or somehow protect this signal to not influence others, and to protect, let's say, 2 or 3 wires. So now, some examples. Yeah, we have parallel ATA. This was the HDD interface for the old computer. Now we are using serial ATA, and we now SATA most probably you can find even as external interface for the additional. Now, LPT port, parallel port. Yeah, parallel port of the computer was replaced by USB. Now printers are connected to USB because parallel ATA was not so and it was too expensive. So this is about what kind of interface. But generally speaking, it is you can have some sensors with binary interface, yes and no. Yeah, you can have analog interface that we can convert after, or we can have already some sensor that are providing already processed data, but can be provided by serial or parallel interface. So just please give me some level of understanding of serial, parallel, or digital, let's say. Please provide me some feedbacks if you understand what is the difference between parallel and what are the problem there and on the parallel and the serial. So you'll see that everywhere, and now USB became a computer standard. We can send even video signal, even not using HDMI, using the USB. Okay, Type-C, USB, but because of the technology, we can raise the frequencies at a very high level. Okay. By the way, VGA cable, it's more related to the parallel interface. So, but there is another kind of interface, the interface timing interface. So let's imagine we have a certain value or certain signal that we want to send, and we have to send this value from one point to another via one wire. What is interesting that usually signals, as we discussed, can be influenced by some noises. That means instead to have this value, we can receive this value. Yeah, you see, we wanted this to send this value, but somehow because of the measurement and because of the influence of the environment, some electromagnetic fields, some I don't know, some phones. Maybe you already heard when you are driving a car, and somebody is calling you, we have some magnetic fields, and your phone start to communicate, and you will see some pick, 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 pick on the why, because we have some electromagnetic fields, and there we have some wires that are influenced by the noises. Yeah, and even high value filters sometimes are not enough to let's say filter this information, yeah, or these noises. So in this case, what we can do? Okay, the electromagnetic fields are influencing the value of the signal and the amplitude. Yeah, but what if we will say let's convert it not from the value domain to the time domain, and we will send an starting of the pulse and we'll measure till the end of the pulse. Okay, so now we'll see that the electromagnetic fields will influence the amplitude, yeah, and we can cut it. So in this case, we can have a stable signal on the value. Yeah, never will have. We cannot have noises here. So this signal means that we are sending the value in time. Yeah. So sending a lower value, we will have shorter pulse, and higher value a longer pulse. So we can have, depends now of the system, we can have different kind of resolutions, yeah, of the signal, but in this case we'll have let's say we will protect against the noises that can happen on this, yeah. But it's not exactly the same, but okay, it is very now on the let's say state-of-the-art technology. We are using it very often. Yeah. So we can have the timing. Let's say where we can meet such signal in the sensing, because it's more used for actuating, but it's let's say a timing interface or quasi-analog signal. That means sending analog signal in the time domain. Usually this signal is, the name of the signal is PWM, pulse width modulation. Yeah. So we are modulating the value in the pulse width. Of course, we can have frequency modulation. FM signal. Yes, it is exactly the FM signal that you have in the on the radio, and you will see that in the comparison with the AM signal, amplitude modulation, that is somehow we have a signal that is transferred on an amplitude, and we have some noises here, and on the radio we'll hear this noise. On the FM we will not, because it is sending information, let's say on higher frequency it's higher value, and the lower frequency lower value, and this is why we have a clean, because it doesn't matter the amplitude, it's matter how what is the value of the frequency. Yeah, so this is the frequency modulation, and we see that we can have a clean signal on the radio station. So we are converting the value from the amplitude domain to the timing domain. So in this particular case, what we have, we are gathering information from ultrasonic sensor. We are sending this ultrasonic signal from the transmitter, and it is going to, let's say, a wall and going back. Yeah, And once it reach here, we will have this trigger. Yeah, we have this toggle of the signal, and when we will reach back on the microphone, we will toggle it back, and we will have this signal on some wire. What we should do in the microcontroller to measure this value, yeah, so it will have time, and from the time we should convert it into value. So how? We will see in one of the laboratory works maybe. So next. So generally about the interfaces, do you understand the topic of the interfaces? What kind of interfaces we have and what is the differences from 0 to 10? Please provide me some feedback. Or if you have any question at this point, please. So we can have different, yeah, we can have binary interfaces. Yeah? We can have analog, okay, infinite resolution. By the way, we are converting into the finite resolution. We can have digital interface. That means already processed data and provided ready to use. We can have even timing, yeah, when we are sending value not in the amplitude as an analog signal, but in the time. This is the general class of the information. Okay, of course, there are many different types of interfaces. Even in digital interfaces, we can have thousands of protocol or hardware protocol, but in this case, we will discuss in the communication chapter. So, next classification criteria is we should localize, or we see we can classify sensors by the signal source. What that means? We can have interoceptive signal or exteroceptive, meaning that the system is measuring temperature of the, or the source of the signal is internal in the system or somewhere outside. Yeah, we can, example, we can measure the temperature of the CPU that is inside, or the speed of the chassis, or the position of the chassis. Yeah, and the robotics, or what we can measure even. I don't know, battery level. Yeah, in this case, the system is measuring its own parameter or an internal parameter, or from another point of view, it can measure an external value. Value of, let's say, a foreign value. And in this case, we can see that when you are looking to the datasheet of the sensor, you will see the proposal of the sensor, because once you are measuring the outside temperature, you will have a special construction of the sensor in order to gather many or biggest area in order to have the average value of the temperature. Yeah. In case of the internal temperature, we can have, of course, some material, and we can just touch it and to measure very precise. Outside is different problem. So in this case, we can see the next criteria is to measure, to classify what kind of sensor I'm using. I'm using the sensor of the my speed, meaning I can measure the wheel speed, or I'm measuring the speed of the vehicle that is in front of me. How can I do that? Just having a radar system. Yeah, in this case, we'll have an exteroceptive sensor. Next classification criteria, we will have the localization. Where is the sensor? Sensor is inside of the system, or it is outside of the system. So now, please, let's make an experiment, and we can say, let's measure the temperature in the place I am. Okay, I will measure the temperature in the near the university, and I will use, I can go outside to have my local system sensor, and I will see the value on the screen, or I just can consult the video system that is on the phone here. And please take a look on your phone and just provide me the information that the global sensor is providing to you. For me, it's 8 degrees. For me, it's 8. For you? So that means that I'm using a sensor that it's somewhere else, and it's a shared sensor that can be used by different systems. So in this case, take a look. We can use also a temperature. Okay, internal, external temperature. Yeah, internal temperature, that means CPU temperature, or the environment temperature. Maybe I have some add-ons for, or even I can use a global sensor to measure the temperature. You see, different sensors and for different proposal and different methods. Okay, thank you for. Now I can detect where you are, because looking into the map, I can see where is the level of the temperature of 8 or 9 degree, and I can say, okay, it's far from me. So who is 8 grades? It's nearby, most probably. Somebody's on the south, somebody on the north. Okay, but anyway, just some association to. Yes, Nikolai.
No, misclick.
If you have any question, please.
No, misclick. Sorry.
So next, we can have different criteria. Another criteria, okay, in our case is number 5. What kind of sensor is an active sensor or a passive sensor? What means to have an active sensor? An active sensor, it means that it generating an action, something, it's activating, let's say, the environment in order to extract the parameter. The passive sensor, just measuring it. Some parameter you can just measure, but let's say we would like to measure the distance. And in this case, ultrasonic sensor, what is doing? Is just emitting some ultrasonic sensor and waiting until this wave will reach back. In this case, we'll have active sensor. But in case of temperature and regular temperature, we just measure even the color, yeah, or color of the sun. Okay, in this case, I can measure the temperature of the sun, but I see the color, and we'll see exactly, most probably, the temperature. Who knows? Yeah. Okay, taking account the mathematical models and so on. So just observation. Yeah, in this case, for the active sensor, so usually, what is the difference from another perspective? Okay, everyone is measuring some, and there are different methods, but usually active sensors are more power consuming sensors. Yeah, more than it is disturbing the environment and can even influence other sensors. Let's say that we have 2 sensors, one here and one here. Yeah. In this case, when I activate the environment, most probably I can catch back not the reflection, but the signal that was transmitted by another. So always this sensor, the minus is that it is power consumption, and it can influence another sensor, and sometimes it cannot be used. Let's say in the army, the detection of the submarines usually is done by echolocation, but in the moment you are echolocating some submarines, the submarines detects you exactly your position. And in this case, let's say it's not so, it's very complicated or very tricky when to detect, what to detect, how to detect. Yeah. So this is the difference. So when the sensor is using or used to make some action to the environment, it's an active sensor. Camera usually is a passive sensor, but we can have, let's say, we can use the camera in order to detect the distance. Yeah, we can project something on the field and we detect back the reflection and see where it is positioned, because I know the angles. Yeah, and I can see where it is positioning. Okay, let's see. Somewhere we'll have, by the way, measurement methods after. So let's go further. We'll see after this story. But classification criteria, the last three classification criteria, when we will classify, we'll see that we can have passive or active sensors. So we cannot have active, let's say, internal and global at all. Yeah. Why? Because global and internal. Okay, global but internal. Internal measurements usually I'm doing by local sensors. Yeah, and usually I'm doing by passive sensor. Okay, external and so on. So in this case, we can classify, and every sensor we are putting it on a specific place, and in this case, we will see what kind of sensor and where it is, and we can, let's say, define the sensor. And in this case, I would like to have everything global. And in terms of Internet of Things, by the way, we have global sensors, and our control system can be everywhere or somewhere around the world. Yeah, we can do different things, but the globality is very interesting in terms of Internet of Things, the shared sensor. So now please just the level of understanding of the last three criteria, meaning the internal, local, passive, active, global, local, 0 to 10. Because having this criteria, you always you will have some association to understand how it's work and why you are using it. Because for the internal sensor, usually you need some small sensor and cheap sensor, and for bigger distances or for the external sensor, you need more complex sensor and so on. And you always, when you understand what you are measuring, you understand what kind of sensor to use. And this is why we are going to understand what is the process of gathering information and what kind of situation we can have. So next, let's go to the acquisition method and how we can measure the temperature. The easiest way to measure the temperature is thermocouple that we can build from two wires of different metal, just not soldering it, but how to say, sudur. I don't know how to say in English, but just put some
welding.
Some welding, yeah, and we'll weld it. And after that, always on a certain value of the temperature, it will create on another side some voltage. And okay, it can be used as a energy to collect energy, but it's not too much. But we can measure this voltage, and we can detect temperature and even high temperature. And usually such sensor can be used for the flame temperature measuring. Now for lower temperature somehow, but depends of what kind of materials, and we have some tables related to this. We can find different data sheets, let's say, and we'll see. Yeah, and here we are measuring, and we see that we can measure by this construction of this sensor, we can measure the analog data and the level of the binary. Yeah, we can by this potentiometer, we can put a threshold, and in this case, we can say do we have flame or not? Where we can use that? Okay, in protection of the plita di gas. Okay, and you also will hear in the gas, let's say, in the kitchen, yeah, when you are switching off, you'll see that it is something is happening there, and it's protecting to not have gas outside, but we can use such sensors. And you will see, of course, this sensor that is going outside from the gas station. Okay, humidity, very easy. We know that humidity is providing, it's conducting current. That means virtually we will have a resistor here, and we are measuring this resistance. Okay, and here we have another resistor here. In this case, the measurement method is like this. We have this one here, yeah, and this one is here. Powering it, this is on the ground, and from here we'll have, this is very easy how we can measure the humidity. Of course, there are another principles that is better quality sensor, because the problem here is that this material also is changing on the humidity, and so we cannot use for long term such sensors, but this is a resistive sensor, but we can use capacitive sensor. Okay. Rotation. Oh. Yeah. How we can? Just measuring how many holes and how many pulses we have per minute. Yeah. Direction, we can change a little the phase of the this encoder, and in this case, when we have rotary in one direction, this will be in front of the phase. Yeah, this is will be a little changed, and depends if this one is first pulse. Yeah, and we'll have a kind of 0 0 0 1 1 0 1 1, and now depends what is the next change. If we'll have change from 0 1 to 1 1, yeah, 1 1 and 1 0, and now depends from the 1 1 what will be the next. If this one, in this case we have one direction, otherwise we have another direction. Very easy with just some holes and some light sensor. And always we will see it now on the motor and in the vehicles. By the way, in electrical vehicles, all the electrical motors has this such system. Very easy. On the mouse, by the way, you have the same. Pressure. Okay, just when we are putting some pressure on the material, it's changing its resistive properties, and we can use such schema in order to measure it. Very easy. Of course, ultrasonic, you already know, we are pushing some ultrasonic signal and waiting when it will come back. Measuring this pulse, yeah, we'll have the distance. Laser distance, how it's working? It's just a camera, low resolution camera, or just one line camera, let's say, with one pixel on one line. And we are providing some lights, and when it is coming back, it's coming here. But in case we'll have here, yeah, we'll have something like this. And now seeing where is the spot. If the spot is here, that means it's farther. If the spot is here, it's closer. Okay, next, touch sensor. We already discussed about that. What we have here, we have just another measurement methods, 2 resistors. Very easy. Yeah, just measuring the level of the voltage, and we can see the coordinate X or Y. Yeah. Next, how we can do motion detection. Yeah, and everyone has a mouse and how it's working. Very easy. It's measuring the movement of defects on the table. And now let's see how we can do that. Where is my point? Okay. It's making a picture, and after making the second picture, it is moving and checking the picture moved here in this direction, this direction, this direction, this direction, and is looking which of the moved defect image is better, is the best match with the current picture. Okay, the previous picture is moved in many directions and is compared with best match the current snapshot. And in this case, it will detect exactly what is the direction. So usually in the camera, okay, in the laser mouse, the laser is just for lighting, and otherwise the camera will not be able to measure the movement. Why? Because no lights, no picture. So, and now you will see that there will have a kind of lens that is focusing. First time before I knew that, I thought that really here is the laser that is something is doing and we are measuring something. No, but it's just a camera and low resolution, usually 16 per 16 or even higher resolution for higher precision, but it is just a camera and we are measuring. So finally, what we have from the interface of the system, yeah, we'll have here a sensor, and on this side, by let's say this line of code, how we are measuring. We're just doing analog read for the analog signal, digital read for the digital signal, and pulse in for the pulse. For the other interfaces, we can do like serial read, yeah, or parallel read, yeah, or analog read or digital read are the software interfaces that are gathering the raw information. And on the next lecture, we will see how from this information that is from okay, just a little from the what's happening from the 0 to 1023 to convert it to the voltage and to not have these noises. Yeah, and so what we will do, the raw data, we will condition it, because this is just a raw data and we cannot say that somehow we are converting in our brain, but we need that the system to know exactly what is the temperature and to provide it on the screen. Yeah, and next time we will see. So for today, that's all. Just I need less feedback from your side, the level of understanding, and that was interesting for you from 0 to 10. Please provide me this feedback, and that's all for today.